Hello everyone, so I thought I would make a little dev vlog here with the Nintendo Entertainment System programming stuff that I've been doing. And okay, let me show you what I've done a bit. It's not much, okay. Here we've got some letters and numbers. Now I put these in myself, so like 1 and 2 look terrible. I can fix that. Now I don't think... somebody made a YouTube comment about this, I think, that bitmap fonts in English in America are not subject to copyright. You know, bitmap fonts, these are bitmap fonts as opposed to, say, vector-based fonts. Is it called vector-based? Anyway, you don't care about that too much. So what I'm saying is I could probably just take it from some game. But I figured I'd try just putting in the data myself. So we'll see that. I'll show you the code here later. I just want to demonstrate some of the stuff I've done. So here's another one. Beware, there's going to be some bright color here. There's a little face. Magenta background. Let me see here if I change... that's really big. Let's see if we change 3C... This one. Is it this one? Yeah, I mean, I forget. I think it's... No, it's this one. Okay. If I change this to 3C, I think we'll get a cyan. Let's see about that, eh? So, the way I do this stuff... Go here. And I've got a script set up to do the compilation and all that. This is not meant to be a tutorial, but I will... for those of you who are interested in learning this stuff, I will give some advice. It's not easy, and I'll tell you what the best tutorial is out there and how to go about learning it, because most of the tutorials you're going to get a really pretty incomplete set of skills, in my opinion. So it's a bit tough to learn, but anyway, it's not actually the point. I'm not ready to make full-on tutorials yet, not at that level yet. Let's see, is it... Yeah, it's like this magenta. Not, sorry, it's like a light cyan color, which that's just 3C here. I'm using that C for cyan is how I'm thinking. Even if you go 2C, I think that's going to be another cyan, another shade of cyan here. Let's see. That goes. And I'm literally dragging this in here like this. You know, after compilation, so you can see that's another shade of cyan. Cool beans, you know, cool beans. Like, we can go Nes palette. You get this stuff. And, so this Nes Dev is a major website. Well, it's the one that has the most, sort of reference material, if you will. It's not meant to be a tutorial so much. Though they do also have, we'll take a look at this. But anyway, the palettes, yeah. Here's the colors, so I put in 3C. That's right here. It's this lighter cyan. We did 2C. That's the... I think this is a cyan. I guess these are the main colors, and then these are... Look at that. These are lighter ones. I'm just realizing this stuff in real time. These are more saturated. So these are like middle of the road. This seems like a pure cyan to me. But it was saying... like the actual colors that it's set to are not like set in stone, if you will. Most emulators can use a predefined palette. Yeah, I've been noticing, you know, depending on the emulator, there's different stuff coming out. I mean, so I guess Nintendo has never released any actual information detailing specs of their system. I mean, that's... To them, that's proprietary information. They don't want to really share it, so that's the way it goes. So a lot of this stuff has been reverse engineered. So like you'll hear names, like even palettes or the background information is often referred to as name tables. I believe these are made up from these names. Are made up from the community, if you will. The what do you call it? The emulator community, the reverse engineering community, the NES homebrew community, all that jazz. Let's see, they have tutorials, they have a programming guide. Yeah, this is the main reference here, but it's a lot of information. Now, let's see, programming guide, cool. Before the basics, I'm guessing this is like you're explaining hexadecimal. Those of you interested in programming, if you don't know what hexadecimal is, definitely find out what that is. What else we got? Oh, installing CC65, that's the assembler that I'm using. There's another assembler out there called Nes Dev. Beautiful name. But let's see. We're gonna have that. I just realized you can't necessarily see everything on my screen here. Hold on. Let me try to make that a little better. Yeah, this is a bit of an impromptu little vlog here, and hopefully there'll be more. There's another one program which has some movement in it. I'll show you in a second. But let me finish my thought here. Okay, so this is my directory Nes code that I've got. And so this is the stuff I've been working on lately. But okay, there's the Nerdy Nights tutorial. There's a handful of tutorials out there, say on YouTube and just in text online. If you do Google search, you know, NES programming tutorial, etc. Nerdy Nights is the best. However, it is also sort of the most difficult and sort of intense. There are no videos associated with it, but this is where I got the most information. Most of the tutorials out there, they don't really show you how to move things, I found. So I went through a handful of tutorials and I'm like, okay, but how do I move something? And in a way, it's not, you know, it's not super difficult, but yeah, they just, you know, it's one of those things, like if you're not shown how, because you're a beginner, it's really tough. So let's see here. I want to show you the other program that I haven't shown you yet. That one, is that number 11? No, it's number 10 here. I'll show you this this bat file. Okay, if you're a Unix person, like you're from the Mac world, that's like a shell script basically for Windows. They call them batch files. I call them bat files because they're .bat, but they're called batch files. Anyway, yeah, it's just this is where my compiler is located. You know, it's got a bin directory, blah blah blah. Oh, this is the linker associated with that, so I'm using this one. So you have these two different assemblers, okay, right, to compile the code. And based on a Reddit comment, there's a Reddit thread, I don't know, a few years ago, and somebody said, well, the top comment was that, well, the Nes Dev compiler is not really in development anymore, so they recommend this one because it's in active development. I mean, it's not like things are changing, right? So NES is NES. It's not changing over the years. Anyway, use both if you want, but I couldn't for the Nes Dev one. So the CA65 one, I guess it's called. It's not hard to set up, but, or at least it wasn't for me. Leave a comment if you have trouble at any stage. If you start learning this stuff, you have trouble at any stage, just leave a comment. I can make videos on particular topics, like how to, if you're having trouble getting the assembler set up. Now for the Nes Dev one, I tried to get it, okay, but now if I were on a Mac, maybe things would be more straightforward. Here on a Windows, I had to, or if I were on Linux, but here on Windows, I had to, I didn't have make, okay, so I had to get make. I think it needs CMake as well. And you know, the terminal in Windows is garbage, okay, I'm sorry, it's garbage. And I got a lot of little complaints about that. But anyway, I couldn't compile it from source. I think it might even be designed for like an older version of Windows. I didn't see any binaries up on the GitHub page either. But what ended up happening, so here's the Nerdy Knights tutorials. There's a main tutorial, there's an advanced one, which gets into things like scrolling, which I've studied scrolling a bit, but I haven't really implemented it. And so I'll be learning more about that in the future. Scrolling is a little complicated. And anyway, so you get into like here, maybe the third one. I'm not sure exactly when, but at some point, whoever created this tutorial series, they started putting the executable of their assembler in with the project here. They don't do that in the first one or two. Yeah, see, the first one doesn't have it. And the second one, I think I copy-pasted it over, probably. But you're going to need this compiler, obviously. Now, these project files also have a little bat file, and but it's really simple. It just compiles it. Like there's, yeah, it's an amazing file, you know. Okay. So I was really happy when I accidentally discovered that, oh, in like the third project or wherever it is, maybe it's later, they give you the executable for the assembler. Hooray. So, you know, I didn't need to struggle with compiling it from source and all that. However, I should say, although it's obvious, but, you know, this is a security thing. You're running, if you do this, you're running an executable that you downloaded from the internet, subject to man-in-the-middle attacks, and maybe it's not secure. I have no idea, but I couldn't find any other way to get this binary. If anybody else knows, you know, a safer way to get it, that would be great. That'd be fantastic. You know, sometimes it's NESASM 3. That's what I have. There's a NESASM here. I'm not sure. I might have put that in there. I think I was trying to compile from source and then put that in there myself. Maybe. I don't remember. Anyway, doesn't matter. So, that's good to know. So then you can get... That's how I got NESASM. Now, you know, as you develop your skills here, you kind of want to be able to take code... It's not a necessary skill, but it's nice if you can take code that is written for one compiler and then switch it to another one. So let me see here if I can find some code that... So this is... and there's two types of headers. So I believe... Yeah, I think there's a Nes 2 and then there's an iNes. I'm guessing this is Nes 2. I don't really remember about the details on that. Here's an iNes header. Yeah, I'm sorry, I just don't remember. They're pretty similar anyway. Yeah, I'm trying to find an example of some of the code. Oh, you know what? I'll just go into this Nerdy Knights tutorial. Let's look at this first tutorial here. So this stuff, this .dw, this is NESASM stuff. This .bank, .org, this is just including a binary with a bunch of character data. So that's pretty straightforward. But I don't know, the way that NESASM seems to organize data seems a little weird. Like, I think it organizes it into 16 kilobyte little banks, which seems weird to me. This is just my armchair thoughts or whatever, but yeah, so this .inet, this stuff here, the way this header looks is NESASM stuff. So, and the .org, the .bank, that's all NESASM. So, I've taken code from here, from Nerdy Knights, and, you know, changed it a bit so that it works with the other compiler. Because that's the other compiler, I should know what it's called. I believe it's just CC65. But But there's also so CA65 is for assembly, and they have a CC65, I think, is for doing this in C. Anyway, so for example, this .dw, I don't know what this means, double word, I have no idea. But these, you can replace these with, I think you can replace this with .byte, if I'm not mistaken. That looks wrong here. Anyway. Yeah, so I mean, it was a bit of a, you know, it's not, this has not been an easy journey. You know, in the past I've learned things like JavaScript, Java, Python, C, C++, a bunch of other languages, C#, you know, a bunch of things. And this was, so the 6502 assembly itself is not too bad, but learning how to code for the NES is not easy. I will say I've tried before to learn Rust and never succeeded. Rust is confusing to me. But anyway, that's not the point. Now, you can kind of see... So, I have some live streams here that I did. 6502 assembly. These three here. And you can see... it's funny, YouTube caught this image of me being a bit frustrated here. At the end there. And actually... there was one instruction I kind of didn't understand, and at the end here, I finally understood it. So there was one thing that gave me a little bit of trouble. Now, so I streamed this a month ago. Like almost a year ago, I spent some time studying all this stuff. So it's not my first time doing this, but I mean, there's a bunch of... So I would strongly recommend, if you want to learn this stuff, that you study 6502 first for a significant amount of time. Let's say spend at least 50 hours with 6502. And hopefully, if you have some favorite algorithm, try to implement that. And... you know, that's what I did here. And I never fully implemented it. But I spent a bunch of time working on it, and that was great. This was extremely helpful, these live streams I did. So I attempted to implement some algorithm that I like, that returns permutations. Anyway, yeah. So if you don't have I'm just saying, if you don't have a favorite algorithm, or you can't think of anything to implement, you know, you can look at these live streams for inspiration. Yeah. But it's really good to get some practice here, because then after this, when I started looking at the NES tutorials, you know, it was easier than it had been in the past. I think... when I first did this stuff like a year ago, I tried to learn all of this at once, and it's just too much. You should really focus for a while on 6502 assembly, and then move to the Nintendo Entertainment System stuff, because it gets a little complicated. So this... I don't know why I'm going through this, but... this first tutorial with Nerdy Knights, I'll just give like really bird's eye overviews here. Now, and this is not meant to be a tutorial, so I'm gonna tell you like certain things. I'm gonna say this is just like initialization stuff. Just this is how you get started, and you know, you can dig into the details, but a lot of it you don't need to really worry about. Like here's a header. I mean, if you're studying this stuff, you should learn maybe what the header does, but honestly, yeah, I'm not going to talk about it today. It's just, yeah. But you can, for now, you can just think of it as initializing some information. You know, there's nothing dynamic going on. And then reset is where it's almost like your main function, if you will, but it's where execution starts, essentially. When you power the system on with the cartridge in there, or obviously if you reset it, goes here. But actually you can name this whatever you want, and then down in the vectors section you can... every program has these three vectors. I don't know why people call them vectors, One of them is for reset. The other one is this important NMI thing we'll get to later. So remember NMI, that's going to come up. Yeah, so this is not a tutorial, so I'm not going to really go into detail, but this is just some initialization stuff, and then we wait for this thing called vblank, and it's all so for today I'm just going to say it's sort of like the PPU, which is like the GPU, just sort of saying, hey, I've basically finished a frame, here you go. Saying like, hey, I finished a frame, basically. So we just kind of wait. This sort of loops in a circle and just waits until PPU says it's ready. And then it will exit this loop, and it just, control flow continues down here. This is about clearing memory. And you'll see like every program has this. Then we do the same thing again. We're waiting for vblank, and then we do stuff. And this program doesn't really do anything, because this is basically like this stuff you're going to see in pretty much every program. This you can think of as initialization, clearing memory. And so here's the, so all they do is they demonstrate one random thing, like there's a, so this is a space in memory that related to the PPU, and you can set certain settings. So they just, one of them is intensify the blues. I think there's an intensify reds. You should never really do those. The graphics will come out looking weird, I think. Anyway, just for demonstration, they do that. They enter a infinite loop, and remember when I said the PPU has this vblank thing? Well, now maybe I'm getting this mixed up, but anyway, when it's finished with a frame, it does this NMI interrupt. And so that's going to come here. Yeah, I think I'm mixing up vblank and NMI. So I need to research that and figure out what it's actually about. There seems to be a difference there. Anyway, when a frame is basically finished rendering, it goes to NMI. And right now this is doing nothing. So all it's going to do, it's going to be in this loop. And then occasionally the NMI will get triggered. And it'll go here, and then it just returns, and then it goes back into this loop. So it's doing nothing. So that's the background one. And yeah, I mean, you can build up from there. I mean, we'll go look at the sprites one, because it's going to have a lot of the same stuff. This is, again, the reset. This is identical to, or if it's not identical, it's very close to what we saw before. So this is sort of initialization, clearing memory. The second, waiting for vblank. But now here's the new stuff, and then it loads these palettes. You can think of the graphics on the Nintendo as having the background and the foreground. Of the foreground we call sprites typically. The background, sometimes you call it a background, but it also uses these things called, what are they called? Name tables. So if you hear name tables, associate that with the background. Anyway, so both of those, the background and the sprites, you make use of palettes. So if we want graphics, we got to load these palettes, and it's basically a selection of 4 different colors that it uses for rendering. So yeah, we got this is just about loading the palettes, and the palette data it has actually down here. These are just bytes, and this is hexadecimal. So if you don't know what hexadecimal is, definitely learn that. And then, yeah, so they're doing that. And now they're, this is all just about rendering a single sprite. I'll explain that in a second. Then it loops forever again. And now we have this NMI interrupt, which here, actually it is telling the PPU to, or sending the data, sending the sprite data to the PPU each frame essentially here. I think that's what's happening. And this is the actual rendering of the sprite. But anyway, this is not, I'm not going to be able to go through all this and everything. But then I have my own stuff, and a lot of it was just copying in tutorials. Here's a tutorial from is on YouTube. It's like all you need to know for NES development or something, I think is that one. And yeah, just leave a comment if you want me to direct you, if you're having trouble, if you want this, to find where this is from. I can, just tell you. But, okay, so there's a bunch of different tutorials, and so the one I haven't shown you yet, let's see if I can find that here. Just this one, it's just moving this object. So basically, in the last couple of days, there have been 3 projects. I showed you the one with text. I just showed you this one that moves, and then I showed you also the one with the little, it had a little face, and the background was magenta, and then I changed it to cyan. Those 3. So here also we have these vectors. I said reset NMI. There's a header, different format now because we're not doing the NESASM stuff. We're doing the CA65. Anyway, all programs have these 5 sections. So there's a startup section. Here it doesn't do anything. But here are 4 of the sections. So there's a code section. And there's one more is the chars, which has some character data, which I'll show later. Anyway, so again, it's the sort of same initialization stuff, the reset, waiting for the PPU, clearing memory, waiting for the PPU again. Now, again, loading palette information. And then, so enable rendering, goes into this loop. And then we have this NMI interrupt. Now, this code right here is a little... I in my later 2 projects, I change it. This one is just showing text. Okay, so this code right here to me is not written in the easiest to understand way, so we'll see later. I make it a little easier. But anyway, we've got palette data. This has sprites data, and so this says, let's see, I'll show you this one in case you forget what it looks like. Number 9 here. So, hold on. So here are the sprites. Now, you can only do 8 sprites per scan line. That's why there's 8 per scan line here. That's why sometimes the NES, there's the flickering, because you have to implement flickering if you want to, create the illusion that there's more than 8 sprites per scan line. The scan lines are vertical, or sorry, horizontal. Okay. So, for example, this 0, the top left one is this. The next number is this. And this has the Y position. This is the X position. Don't ask me why it's in that order. This is the sort of the sprite tile number. So this data, notice it's 0, 1, 2, 3, 4. It just counts up with that. But that data is down here. So this is the 0, which coincidentally is the number 0. If you look at these 1s and 0s, do you see that it's drawing? It's literally drawing a 0 in the with the 1s and 0s. So here's my 1. It looks bad. Here's my 2, 3. You see in the 1s and 0s here, there's a 3. Here's a 4, and so on. So this is actual character data. It is what, 8 by 8. You can change it. I think you can do like 8 by 16 as well. So yeah, that was here. So this is 0. So you get to like, this is A. This is hexadecimal, of course. So this is G. This was F. And this is G here. So we had Y value, tile number, X value, and this middle one is attributes. Each sprite has some attributes. For example, the palette number, you can have multiple palettes. And there's some more information. I haven't fully learned everything about it. But yeah, that's all the sprite data, basically. that tells it, you know, where to position what sprites. Obviously, we're going to need that information somewhere. Okay, so I could move this, for example, let's try moving the 0 here. Let's see, let's move it to 6C. Let's see where that is at. Now I'll compile. Zero, oh, sorry, it's the Y value, right? Yeah. So there it is. Now, okay, let's look at the next program. So this is the one that moves it's actually, yeah, it moves the sprite, but it's actually a 0. It's the sprite for the 0. This is number 10 here. And just load that in. Yeah, it's actually a 0, but it's moving, which is cool. So I explained this before, not really, but that's the header, there's the vectors, there's startup code, it's the same stuff. Reset, this is all initialization, we load the palettes. This is the same stuff. Now here's where it's different, but we have the same, this is some palette information. So I'm still figuring this out a bit. Before I demonstrated messing with this a little bit. I changed the background previously when I changed it from magenta to cyan. But I'm not sure. There might be more data. I think there's more data here than we need. But we've got, I think we've got 8 different palettes here. And then here's the char data. So we've got 0, 1, and so on. And then, yeah, down to the letters and all that. That part is unchanged. But here we have that movement, right? So, and here's our infinite loop, and then here's the NMI. So this is like, well, the game goes into this loop, and then basically it's just stuck here. If there was no NMI, which again is like this interrupt, it happens on the beginning of the 241st scan line. So I think that's towards the end. I forget exactly how many scan lines there are, but that's towards the end. So it's basically the PPU saying, hey, I'm basically done rendering a frame. You can kind of think of it like that. So, yeah, so if there were no NMI, it would just be in this loop forever. But there's an NMI. Now, this part, I could have put this down here, but the idea here is that, you know, this is kind of a function. We call it a subroutine here with assembly, but yeah, so this is a subroutine, and this is my sort of initialization of variables, if you will, just sort of separated. And I believe if I take this part out, let's see, let's comment this out. I don't know why it's not commenting. But let's see, it should, actually I don't know if we'll be able to see the sprite. Let's see here. No, we can't see it. But if I change this, we'll be able to see it. Hold on. No? Okay, I don't want to get too much into the weeds here with this. Oh, you know what? Okay, no. Hold on, let me see if this works. There it is. So this is sort of, you know, in the middle of the screen, but I suspect that the top left pixel is the middle of the screen here. So let me explain this and then explain how it's moving. So this is just rendering a sprite. Basically here. So now you'll see there are these memory addresses of 0 to 100 something. Then there's this memory address and this memory address. These memory addresses are what you do when you make use of them when you are rendering a sprite. And admittedly, it's a little weird. I'm still getting used to it. So let's see. Yeah, here in the reference guide, you can go to the PPU. And if you go on registers, there's a lot of information here. And it is a bit overwhelming. I didn't say this was easy, but so there's this. I'll try to make this bigger so people can see it better. This information is important, and you find yourself coming back to it. So I kind of want to sort of memorize some of this, but so the way I think of it right now is that this stuff is sort of initialization kind of stuff for the PPU. Well, you've got status, PPU control. Yeah, I think of this as initialization. My thoughts on that might change later, but yeah. Then the other stuff here we have 2003, 2004, 2005, 2006, 2007, and then 4014. So scroll I haven't done yet, so that's kind of in the middle. So I try to remember this in my head, and these are, you kind of think of these as two blocks of similar thing going on. So here's a block 2006, 2007. Here's a block 2003, 2004, because there's an address here. So there's a read-write address, and then there's the data. And here there's a read-write address, PPU address, then there's data. So similar pattern here. So anyway, you find yourself coming back to this, and so that's here. And yeah, I don't really know it well enough to explain in a kind of tutorial way, but all the tutorials will have something like this, or they should. And but I think what's going on here is just setting a low byte and a high byte of 0 and 02. So it's actually telling the PPU the data is stored in 0200, right? High byte, low byte, 0200, which is this stuff. Now this 0200 address, that is on the CPU. And I don't think it's required, but it seems like everything I've seen, everybody stores their sprite information, their sprite data in this 0200 page. They're called pages. But it's just so let's see if I can find. Let's look at the CPU a bit here. There's an APU, that's for audio. CPU, I wanna find the memory information here, the memory map. So here is 2 kilobytes of internal RAM. So this is CPU RAM. If you're using a debugger if you're using an emulator like Messen, which I recommend over FCEUX, then although my code works with FCEUX, and I don't think it works with Messen, but if you're looking to hack a ROM or look at the debugger for a game or something, then I would recommend Messen. As a tool, it's pretty powerful. Let me see if I can bring that up for you here. Hold on. Messen, I've been playing with a bit lately. So like Dragon Quest here, you got a lot of powerful debugger tools. The debugger itself. So you can look at the code for a game. I believe here this is sort of the this is probably the infinite loop, and I'm guessing this is the infinite loop waiting for that NMI. So let me step a bit. Yeah, this is the infinite loop. It'll tell me also the scanline number right now. Hold on. Where is it at? We're at 240. Wow, that's lucky. So the beginning of 241 will be the NMI. I mean, that's crazy lucky that we got right there. So we can step forward a bit here. I'm gonna do step into, and the NMI will be triggered here pretty soon. So I'm going to watch this scan line. I know this is small and a lot of people can't see it very well, but I don't know of a way to make this bigger, unfortunately. If somebody knows, let me know. So I'm going to click this a little bit more. Hopefully we'll get to 241. When we get to 241, this NMI flag right here should be triggered. So yeah, I don't know how many times we click this per scan line. It might vary. I feel like it's something like 16 or 32 or something like that. So I'm just kind of going through slowly. I don't want to miss it. Now, if you want to skip to the NMI, there's this really handy button here. I could just click that. But since we got so lucky with the scan line here, I want to catch it in action. So it looks like the NMI has not been triggered yet, but I think the next time I click this, it's going to be triggered here. We're on scanline 241. Let's see. It got triggered. Yeah, beautiful. I've never been lucky enough to see that. Oh yeah, I have. What am I saying? But anyway, if the scan line randomly had been like 130, we'd be clicking here for like 10 minutes and it'd be annoying. But you could click here instead. But anyway, we got it. So 241. So NMI got triggered. And so this space in memory here in the program memory is the NMI function for this game. And it says that here in the call stack here. The NMI is AB18. So probably in their program they had some label, but anyway, it's a memory address. So here's their NMI subroutine here. And they are pushing the registers to the stack to store that information. Later they'll pull it back. Nice little technique, and it's going to do a bunch of stuff. In fact, this is, I'm pretty sure this is loading the pallets. And then let's see. Yeah, the first thing it's going to do is load some pallets. We have, it's sending some data to this 2006 register. So we saw that earlier. 2006, I said, yeah, register for the PPU. This is related to sprites. But I think they're going to loop through here pretty soon and set up the palette information. Wait, what happened? We're in an IRQ. I don't know too much about IRQ. So something else is going on here. Yeah, it's difficult. I'm not at the level yet where I can tell you everything that's going on here. I was hoping it'd go through a loop that would be a little easier to explain. But I don't think we're gonna get it. I don't know. I don't really know what's going on. Okay, but anyway, this is not a tutorial on the debugger, but you can see that it's very clearly very useful. And one of the things I'm doing is looking at code, trying to learn like that. Now this might have to do with the controller. You have these logical shift right, rotate right. These are bit shift operations, which I believe you do with the getting the controller input. Maybe that's what that's about. And yeah, I did it twice. Is that for two controllers? I don't know. But it does it too many times. I think maybe it's not the controller, it's something else. I don't know what it's about, but I've seen it do that before. Anyway, so this debugger, obviously really cool. There's all these other things like, oh, it has a sprite viewer, which actually, I don't know how they do this exactly, but FCEUX doesn't have that. Now, FCEUX has its own tools and debugger and everything as well. The tile viewer. So these are going to be, this is the sprite data. And then we have the tile map viewer. This is going to be the, well, it's for the background. So it's the name, what's it called? Name, not namespace. I forget what it's called. Once I get namespace in my head, I can't undo it. Name map? No. Whatever it is. This is for the background. I don't know. They call it... The reason they have these names that are less conventional, like tile map, is because they're doing this for many different... emulating different systems. So it's not just NES. Name... That's going to bother me. Anyway. Lots of useful information. So... Yeah. This was again, I'll just review this. It's sending this 0200 address to the PPU that tells the PPU where our sprite data is. And this 0200 is in that CPU, the system RAM. So that's what I wanted to say that I actually didn't get to. So we can have so the memory viewer here is nice. And if we go to system RAM, that is going to be, it's 8 pages. So it's from 0 to 800. Well, it's from 0 to 7FF. That is the system RAM here. So the first page, so 00 to FF, we call that the 0 page. And accessing memory in the 0 page is a little faster, so that's used for a lot of stuff. And then typically I don't know what to call it exactly, the 2 page, but anyway, 200 to 2FF is where sprite data typically is put in games. I don't think that's a requirement, but everything I've seen so far, everyone follows that convention. Yeah, so that's why we're sending that address in particular to the PPU, and then so that's this data here, 0200. And so we only have one sprite. Each sprite, you need 4 bytes of information associated with it. We looked at this before, but there's a Y value. Let's look at this one where we had that. Each sprite is 4 bytes. We had a Y value, an X value, a tile number for the sprite, and then some sprite attributes. So instead of putting that here as bytes in this code, we are setting values sort of dynamically with instructions. So the first byte, we only have one sprite. So the first byte here, we're loading in the number hexadecimal 80. Okay, which is the decimal number 128. And we're also setting that. So that first byte is the Y value. And the 4th byte here is the X value. So if I wanted to have a different X value, I can load into the A register a different number. Let's just choose the number 4, for example. And that will set a different X value. And then it's setting 0 into the accumulator, the A register, and then this is the tile number, 0, because it's the first tile. And then the attribute we're also setting to 0, which does nothing. Well, I believe that it will set the palette to the first palette, I think. So let's see, the X value should be changed here. And where was that? Oh, I gotta go back. Hold on. Okay. Oh god. Okay. Here. It didn't change. Hooray! Because I didn't save it. Okay, save. Blah. Drag in the ROM. Okay. There it is. X value of 4. Obviously, it didn't render very nicely, so let's try x value of 8. Let's do that again. And I'll drag in the ROM. Boom. So so that's what's happening here. So now I'm going to instead, so this is an actual number that's being put in. If let's try to fix this in real time, back to how it was before where it's moving. So first of all, I'm going to get rid of this. We're going to have the same x and y value. And then this is a number. So instead of a number, I want a memory address. The memory address 0. So that's the first byte in system RAM. We saw the 0 page. It's the first byte of the 0 page. So you notice this memory address is for numbers. It's a 2-byte memory address because the system bus for the NES is 16-bit. But there's also this 8-bit addressing system, which is has a different name. I think I think it's direct address, 0 page direct addressing, something like that. And so, okay, but what's in this? What's there? We haven't put anything there, so that's what we do up here. That's this, what I would call initialization. So I'm loading into the accumulator the number 0, and then I am storing the number 0 that's in the accumulator at this memory address. So that memory address will have the number 0. Hooray! Actually, let's change it. Let's change it to 0A. Let's change it to 10. Okay. So that will be there. 10, which is the number 16. So this is now not a number. This is a memory address. So this it's not going to move anything, but it should relocate the sprite. Let's see here. Yeah, so it's 16 and 16. And I don't know why there's like an offset. I don't know exactly how that works. But it should be at the XY values 16, 16. I think the offset, yeah, I don't quite understand it. But then now all this is doing is incrementing the value that's in the first byte of the 0 page. This 00 spot in memory in system RAM. So let's see that. It's going to increment it now. And this is every frame. So if we increment every frame, what does that look like? Well, it didn't work. Hooray. What's going on? Increment at the memory location. We have LDA 00. I forgot to save it again. Isn't that beautiful? I normally don't make that mistake. I don't know what's going on. There it goes. It moves. Hooray. Yeah. So, I mean, that's it. That's all I wanted to show today. Thanks, everybody. Leave a like if you made it this far, because you're amazing. Leave a comment with your thoughts and anything that you think. You know, that's what the comment section is for. Let me know what you think if you want to. Subscribe if you want to. That would be cool, too. Thank you. Have a good rest of the day. Peace.